Hello, today we are going to talk about functions, graphing and evaluating functions, and mostly what we're going to talk about is linear functions. Now, a function is a relation where each input has exactly one output. So a relation is a relation of two numbers, how one number compares to another. So an x and a y. So a function means that there's only one input with one output. So that means there's exactly one x for one y. So we can order our numbers here using ordered pairs, so x, y, or we can use a table, a graph, or mapping. Okay, mapping is where we're comparing these numbers and we draw the comparisons like 2 to 5 and 2 to 3 and so on. Now, describe each domain and range. A domain is the x's. Okay? These are our inputs. The range is our y's. And those are our outputs. Okay, so domain is all the x's. It's what all your x's could be. Your range is what all your y's are. Now determine the domain and range of the relation. So here's a relation of numbers. We have a group of numbers. Our domain is all of our x's. So we could just list them. So our domain, this is 1x. Okay, here's an x, here's an x, here's an x. So 4, -2, 3, and 0. Or you could write this as an inequality. Our lowest number is -2. It is less than or equal to x, which is less than or equal to our largest x, which is 4. Now our range is our y's. So we could either list them out, so 3, -8, -6, 1, or we could write those as an inequality. And range is the y's, so we start with our smallest y, so -8 is less than or equal to y, which is less than or equal to our largest y, which is 3. We could that's one way, those are two ways that we could write our domain and range. So how do we determine if a relation is a function? If the x values repeat, it's not a function. So that means, we don't want any repeated x's. If the graph doesn't pass the vertical line test, it's not a function. It should only cross an x value one time. Then if one input has two outputs, it's not a function. So, that means that there's no repeated x's. So you want one x for every one y. So let's look at these. Are these functions? Yes or no? So look at your x's. 4, 3, 5, 3, -1. Well, look, you have 2 3's there. Those are repeated x's, so no, it is not a function. You don't want any repeated x's. Let's look at this next one. 3, 2, 5, -2. Yes, that's a function because you don't have any repeats. Now let's look at these two here on the right. These are mapping. Well, if you look right away, 4 goes to 3, and 4 goes to 1. So if we write those, that would be 4, 3, 4, 1. That means there's a repeated x. So no, it is not a function. You can have an x go to, two x's go to 1 y. That is fine. But you can't have an x go to 2 y's. So if we look at this next one, 2 goes to 7, -9 goes to 7, 1 goes to 3, 4 goes to 2. There's no repeats there, so yes, it is a function. Does this pass the vertical line test? So let's draw a vertical line. Okay, vertical line at each point. Okay, if you look at this point, it only crosses the one all the way to the left. It only crosses the second one once, but here, if you look, it crosses 2 times. Crosses here and here. So no, that is not a function. Here, if you draw vertical lines, okay, I know these aren't the greatest vertical lines. They only cross our x's once. So yes, that is a function. Here, if we draw vertical lines, they cross 2 times. Okay, each spot, at the top and bottom. So no, it is not a function. Function notation is just another way to write equations. We write them f of x. All that means is f of x. It's basically the same thing as y. Okay, y equals. So y equals negative 2x plus 1 is the same thing as f of x equals negative 2x plus 1. Basically, it's the same exact thing, just a different way to write it. Now, graphing. One way we can graph is we can make an XY chart. So what we'll do is we'll plug a number in for x and see what y will be. So I have these numbers. The easiest numbers to plug in are -2, -1, 0, 1, and 2. Okay, for linear functions, we will always be able to plug those in. So what I'm going to do is I'm going to take -2 and I'm going to plug it in for x. So 3 times -2 plus 1. 3 times -2 is -6. -6 plus 1 is -5. Then I do the same thing for -1. 3 times -1 is -3 plus 1 is -2. You plug 0 in. 0 times 3 is 0 plus 1 is 1. Plug 1 in. Okay, 1 times 3 is 3. 3 plus 1 is 4. Plug 2 in. 2 times 3 is 6. 6 plus 1 is 7. Look at your change here. You are adding 3 every single time. That's kind of like how we were writing those equations from chapter 1. Look at your change. We're adding 3 every single time. So if we plugged in 3, well, we're just adding 3, so we'd get 10. Plug in 4, we're adding 3, so we'd get 13. Now we can go and graph these. So -2, -5. Somewhere right in there. -1, -2. 0, 1. 1, 4. 2, 7. Then we can draw our line. Okay? So one way we can graph is make an XY chart, pick 5 numbers, plug them in for X, and see what your Y is. So the numbers I'm always going to pick is -2, -1, 0, 1, and 2. So this one we can make an XY chart. So I'm plugging -2, -1, 0, 1, and 2. So plug negative 2 in. Negative 2 times a negative is positive 2, minus 5 is negative 3. Negative 1, negative times a negative is positive 1. 1 minus 5 is negative 4. 0, plug that in, you get negative 5. 1, you get negative 6. 2, you get negative 7. Now look at your change. Each time you're just subtracting 1. So if I plug 3 in, I'd get negative 8. If I plug 4 in for x, I'd get negative 9. Now I can go and plot these. Negative 2, negative 3. Negative 1, negative 4. 0, negative 5. 1, negative 6. 2, negative 7. Then I can graph them. Okay, so after I plot them, I need to draw a line for my graph. Okay, now that graph would go on, keep going up this way. And keep going down. Okay, so now determine if a function is linear. A linear function, when it is graphed, will look like a line. It's going to look like a straight line. So we could, if we look at these functions and we look at our x value, then a linear function, when we graph it, will look like a straight line. The largest exponent for a linear function. So look at your x value. So look at your x. Look at its exponent. The largest exponent will be a 1. Okay, so it'll look like this. Or x to the first. But we never see that 1 there. Also, linear functions will have no absolute values. Absolute value graphs look like a V. Okay, so absolute value graphs look like a V. Linear equations look like a line. And remember, absolute values will have the absolute value bars with it. So let's look at these. Is the function linear? Just by looking at the equation. Well, find your x on the right side of the equal sign. Okay. Well, this x, if we put an exponent there, it would be a 1. We never write it there. It's just understood to be a 1. So the largest exponent for a linear function is 1, so yes, this is linear. Look at your largest exponent in the second one. It's a 2. Our largest exponents for linear functions are 1, so no, this is not a linear function. This is what's called a quadratic. The third one, you have absolute value of x. Absolute value graphs look like a V, so no, it is not a function. And then the last one, I find my x. Well, it's not there, so it's understood to be a 1, so yes, because our largest exponent for linear functions is a 1. Find f of 2. Evaluate. All evaluate means is plug it in. Plug and chug. So 3 times 2 plus 6. 3 times 2 is 6. 6 plus 6 is 12. So we're just evaluating by plugging these numbers in for x to get our y, or our f of x. So here, 2x squared, this isn't a linear function, but I'm still going to evaluate it. So I'm just going to plug it in for x. So I'll do order of operations. Negative 3 squared is 9. Okay, negative 3 times negative 3 is plus 9, plus 1. Two times 9 is 18, plus 9, plus 1. 18 plus 10 is 28. Alright, so there's all the first section of chapter 1. If you have questions, please let me know in class.